Don't worry about it. You're not going to be tested on it. All right, so let's make sure we understand how functions work. If I have, say, f of x equals x cubed minus x plus 1, and I want to figure out what f of -3 is, well, think of it. It's just a rule, and the rule says take -3, cube it, subtract it from whatever you got when you cube, and then add 1 to the whole thing. In other words, wherever I see an x, stick a -3. So I got -3 cubed minus -3 plus 1. What the heck is that? -27 plus 3. Let's see, -27 plus 3. That's -24 plus 1. Excuse me, is this -23? Smells about right. Now, what if it's h of x equals x squared minus 4, right? Now then, h of, I'm not going to do that to myself. Let's go 4. Now again, oh, it's a different name, Ripley. I'm so horribly frightened. Who cares? All right, it doesn't really matter. Remember, F's and H's and G's. I can use whatever terminology I want. I just got to remember that the y-axis is always this of x portion, whether it's H or F or Z or whatever. So I just go 4 squared. Excuse me, minus 4. That's affectionately known as what? 16 minus 4, or 12. Easy. Nothing to it. Now, what if I want to do something crazy? What if I wanted to do f of x plus h? Ooh, scary. Now, what, Ripley, there's not even a number there. There's this x plus h term. The rules don't change. This is the rule right here, okay? The rule says take a thing, cube it. Subtract that thing from the cube, and then add 1 to it. So at its absolute simplest, I take this thing and stick it in wherever I see an x. Well, there's an x. So I go x plus 1, and I cube it. Or, excuse me, x plus h, and I cube it. Minus, hey, there's an x, so I'm sticking x plus h. I'm going to use parentheses here, otherwise, remember, had God been a mathematician, the 11th commandment would have been respect thy negative. That negative right there will screw you up so efficiently and so often until you learn it. It's one of those things. And then plus 1. Now, students often get screwed up with these constants. It's like, wait, but why don't I have an x? Well, because that isn't an a, or excuse me, that isn't an x right there. Look, if it's not an x, you don't put this thing into it. If it's not an x, you don't put this thing into it. You just leave it alone. All right? So what if I want, I got to get rid of this obnoxious red. What if I wanted to do h of, let's get ugly, g plus 3? What's that going to be? Well, okay, wait, I'm kind of freaked out here. Oh, wait, no, I'm not. Check it out. H, there's the rule. Wherever I see an x, I stick this thing in, because this says h of x. Well, this is h of g plus 3. There is no x. What am I going to do? Well, the rule says take whatever variable is going in. I don't know what g plus 3 is. It's something plus 3. But I don't care, because h says take that thing and square it. G plus 3. I'm going to square it. Because why? Because that square right there. And then I'm going to subtract 4 from it. And in both cases, I will have you guys expand these. I'm just kind of priming the pump, because it may have been a while since you did any mathematics. Okay? Fair enough? Okay, cool. Now, let's talk about domain. Let's go domain and range real quick. I don't want this to be a forever video, especially on the first one. You guys will rebel and run away. Okay, domain. All right, domain. Domain is the set of x's. Now, I realize that it doesn't necessarily have to be an x. It could be a t, but for simplicity, we're going to talk about the set of x's that, quote unquote, work in the function. And I'll define that in just a little bit, that work in the function. And I'm going to be lazy and start abbreviating things. Why? Because I'm a mathematician, and I'm lazy and I reinvent language. All right, the range is the resulting y values. So let's go back to our good friend. What did I do? I did x minus t, right? Let's go back to f of x equals the square root of x minus 2. And I'm going to show you a few ways to do this. All right? I'm going to show you a numerical / algebraic way to do it. I'm going to show you a graphical way to do it, which some people find really, really useful. If you're a super visual learner, then, excuse me, then it's pretty helpful to see it both ways. Okay, first things first. Ask yourself the question, where's the trouble? Where's the trouble in the function? All right? So, for example, what's the trouble with f of x in this case? The answer to that is the trouble is in that square root. Well, what do we know? I know that things under square roots have to be greater than or equal to 0. So watch how this works. If I just say that x minus 2 has to be greater than or equal to 0 because that's how square roots work, otherwise they start grinding out imaginary numbers, right? Then x must be greater than or equal to 2. And guess what? This is my domain. Now, you may see this really fancy written like this. The domain is the set of all x such that x is greater than or equal to 2. For all intents and purposes, this right here is plenty for my class. Okay? Now, what's the range? What's the range? Now, this is where it gets hard if you can't visualize the graph. Okay? The range. Now, think about this. I know that the square root of anything will never spit out negative numbers, but this thing will spit out a 0. I know it'll spit out a 0 when x equals 2, and then the numbers just get bigger and bigger. Square root of 0 is 0, square root of 1 is 1, square root of 2, etc., etc. Square root of 9 bazillion is the square root of 9 bazillion. It's a big freaking number, and it'll just keep growing. It grows to infinity, right? So the range on this guy is going to be that y is greater than or equal to 0. It's going to be, in other words, there's no positive y value that this function won't pass through, which begs the question. All right, now, some people love this definition, and some people are like, Ripley, you just confused the heck out of me. Let's do y equals the square root of x minus 2. See what I just did there? See? I exchanged f of x and y. Now, for those of you that may know how to graph this, or that have learned how to graph something like this, you know you go over 1, 2. This is a shift of the square root of x, which is the mother graph, and it moves over positive 2, because when I'm inside the square root, I move opposite the sign. I know the mother graph of f of x equals root x just looks like this. Okay, now let me explain how I teach this when I teach this in my Algebra 2 classes. I say, suppose that this thing was made, this function right here was made of glass, and it were to shatter. If this thing were to shatter like glass and fall immediately vertically to the x-axis, I would hit every single value from positive 2 to infinity, wouldn't I? Because this guy trails off, heads to infinity. So there is no value between negative 2 and positive infinity that this thing, that when it breaks, that this thing will land on. All right, so the domain is what we figured out, that the domain is x is greater than or equal to 2. Now, let me change colors real quick. Let's go to obnoxious orange. Now, what if, again, this thing were to shatter like glass, and instead of dropping vertically to the x-axis, it dropped, quote unquote, horizontally to the y-axis. In other words, all the shards shifted over here onto the y-axis. Now, notice there's no broken function down below the x-axis, down in this negative y zone right here, because the function itself only lives up here. So when it shatters and gets sucked horizontally, it's only going to hit right up here. So our range, I don't know why I put y there, our range is going to be y is greater than or equal to 0. Being able to graph your functions, being able to think visually about the functions that you're playing with is really, really important. Okay, a couple more quick things, and then I'm done with this section. Thanks for your time and attention. I'll try and get you out of here so you're not completely destroyed on your first night of watching videos. Let's talk about a piecewise function real quick. A piecewise function. All right, a piecewise function is something like this. If I say that f of x is equal to, let's make this one fun. Let's go x squared for x less than or equal to 1. And then let's have it be, I don't know, x plus 2 for x greater than 1. Now, think about this. It's actually really simple to do. What I have my students, again, when I first teach them, what I have them do is I have them graph f of x equals x squared. Just like this. But wait, Ripley, let's call this 1 right here. But Ripley, this thing doesn't live. This only lives when x is less than or equal to 1. Well, that's why we were given a rubber end to our pencils. I'm going to erase everything to the right of x equals 1, because this is f of x equals x squared only when this guy is less than or equal to 1. Now it's equal to 1, so that means that it contains the point f of 1. Now if I had to, I could plug it in here, right? F of 1, this is just scratch work, equals 1 squared aka 1. So this point right here at 1 comma 1 is actually contained in this part of the function. Now let's deal with x plus 2. If I did, let's change, this is the most obnoxious green, but you won't forget. So 1, 2, and then I know that this function, badly drawn, looks like this, right there. All right, now notice my quote-unquote seam is here at x equals 1. Now this little guy down here does not exist. Notice this only exists for x is greater than 1, so it doesn't exist when x is less than 1. So I take the rubber end of my pencil, and I don't have a rubber end of my pencil here, so I'm going to have to digitally mess around here just a touch. All right, and look at what happens. What I get is, to the left of x equals 1, I get this parabola, and to the right, I get the line, x equals 2. Now, what do I do with the seam? I can't put a dot there, or excuse me, a closed circle there. Why not? Well, I know some of you are already saying, vertical line test, vertical line test. Well, think about it. What I've done is I have assigned x equals 1 to 2 points. I've assigned it here, and I've assigned it here. And the rule for functions, if you remember back here a bit, I go way back, the rule for the function is, wow, I've already done a lot of work here, haven't I? The rule for the function, it assigns x to at most 1y. Otherwise, it ceases to, you got it, function. It no longer functions. In other words, I can't plug x equals 1 in and get a value out of it. I get multiple values out of it, which doesn't make sense. Let me tell you a really an easy way to characterize this. If I want to know the number of highway deaths in 1998, all right, so let's take a look at what this function might look like. So this would be deaths, and this is morbid, but it is what it is, and this would be the year. Okay, now let's say that I plug in 1998 and out pops not 1 but 2 values. Well, which one is it? That's not useful, not useful at all. In other words, whatever I'm dealing with ceases to function. So it's not a function. And this is referred to as the vertical line test. Vertical line test, or VLT. Not to be confused with the BLT. And it simply says if a graph is a function, oh, I should have done this on the other page, shouldn't I? Is a function, comma, then any, that's important, any, think of that also as, I'm going to pop over here to the next page, any and every vertical line will intersect, in other words, run into, we as mathematicians like really smart sounding words, will intersect the graph at most 1 point. Okay? All right. I know this is all review for you guys. At least I hope so. If it isn't, come see me, and I can get you guys kind of boned up in terms of what you need to cover as far as review. Okay? So that's the end of section 2.1. Just a quick introduction to graphs. Tomorrow we're going to play around on calculators. We're going to do problems. It'll be a hoot. But again, just to sort of prime the pump and get you guys ready. All right? I'll see you in the next lesson.